My role in the McKinley process is designing procedures to verify the work that has been undertaken, that it has been completed to the standard that was required. When it comes to running the railway, the operator needs confidence that the locomotive will accelerate at the rate that he thinks it's going to and achieve the speed that is appropriate for it. So we needed to make sure that all the CVs were set to appropriate levels for each locomotive. It's no use saying that all CV7 will be set to, I'll pick a number out of the air, 44. Because between the motor, the free running of the locomotive and the actual chip, you may get variability. There needs to be a standard that we can see and say, that's the standard we're setting to. Now what I've done is brought my experience when I was working as an educational psychologist to the checking process. I know human beings have a tremendous ability to think they have done what they have done, but not actually done it. What we have is a series of test sheets. So we've broken down each process into a series of stage parts and designed a simple instruction that guides the person to be able to say yes or no, that that item has been tested and that it has passed the test. And if the locomotive fails, it goes back to the locomotive engineer and it's up to him to sort it out.
Hello, I've got a new Loco here to test the engineering checklist. So onto the track, and I have my checklist. Now rather than go through every single item with you, I'll just go 2 or 3 to give you a flavour of what we do. So one of the first things that we'll check is whether or not the lights on the Loco are going to work. So F0 for lights, turn the lights on, turn the lights off. And I'll check F1, which will turn the sound on. We can hear the Loco is started up, so the sound, we know the sound is running, that's good for us. It will take a few seconds to come on. One of the other tests that we'll do is to check the pickups. So we can check to make sure that the Loco is going to run with picking up from both ends. So by running it onto a sheet of paper, so the bogie at this end is now not on the track, you can hear it that it's still working because the sound is still on, and I should be able to drive it off. And as the engine starts up, we've confirmed that the pickups are working at this end, and now the test would be repeated at the other end. That gives you a flavour of one of the checks. Having gone through all the checks, which there's several here on my checklist, check acceleration, check the braking, does it run forwards and backwards through points and crossovers, until I get to the last one. Does the model need any attention? You know, is it weathered? Is there anything missing? Has a buffer come off? Are the couplings in the right place? They're not too far back. And if all of that passes, then I will, on my checklist, I will tick everything off. And here's one that's already been done. Everything has been ticked off. The Loco is now ready for the next test, usability. So it will now go to join the other ones on this side. If, however, anything comes up in a check, and you can see from this one that there were several items, it will cycle back through the testing procedure until everything has been ticked off and it's acceptable, and then it will be released then for use on the layout.
Welcome to the second part of layout acceptance, as we call it. This is called usability. The first section you heard from Bernie about, which was the more mechanical and engineering checks that we do. Then it moves on, if the Locos pass those, to this usability test. Usability for us is really allowing the Loco to run properly, basically, for regular operators and guest operators. We want to be sure they can put a Loco on the track, they can use the normal controls, and that they can work smoothly. Again, we've got several things on the checklist, but I'll show you a couple of them that are quite important to us. The first is to make sure that that Loco, now it's gone through the engineering checks, actually runs very smoothly through a complicated set of point work and crossovers and double slips. And for those who think that's a foreign language, I'm sorry, but most of you know what those are. So I'm going to run that Loco through at a fair old speed. We're checking not only that it runs smoothly, but on all of McKinley stock we use KD couplers. KDs have a small pin at the bottom that works with magnets, which I'll show you later, and we need to make sure that doesn't foul any of the point work as it goes through. So the Loco's already been checked for sound, it's working, it's already been checked for lights, so we're going to put it up a fair old speed and run it through the throat of Manchester Station. It'll take a few seconds to start up, and then away he'll go. So we're watching all the time that he's running smoothly through the point work. We're also making sure none of those KDs are catching on any of the points. And away he goes. So we don't need to go too far on the test. We're going to rest him just up here because he's already gone through quite a number of points. So we'll bring him back, make sure he works both ways. You can see the lights have changed, so he's now heading towards you. And here he comes back. Now already I'm thinking on this checklist that he's passing at the moment. He's not fouling, there's no complications with the wheels. And what we'll do now then is bring him into a position where he might be shunting some stock. Because as I say, we're using magnets and KD couplers here. So we'll move him back into the stock very gently, as if he was pushing them back into a yard or something like that. There he goes. We'll move him forward again just slightly and back again, so we'll connect him up. Here he goes. Right, he's connected up now. Moving forward over the magnet. And again, we're checking all the time nothing's catching on those magnets. And if we pull him up in the right position, which is usually about there, on our control here we have one of the functions, F9, that we press, and away the Loco's already gone. He's already separated on the engine, and we can move him off now and carry on with whatever work we're doing. So that's just, well, 2 or 3 examples really of the checks that we've got to make sure are okay for anybody operating on the layout. The next step, once it's gone through that, again like Bernie said, we check those off, we sign them off, and he moves on to another section that we call profiling. And we've got one of our colleagues that'll explain that to you. So I'm happy, I'll sign off the checklist and you can move on.
Profiling is where we teach the computer how to run diverse locomotives at the same speed, irrespective of their characteristic and performance. For example, a WD-280 to be run at 40 miles an hour needs to be run at flat out, whereas a Britannia Pacific, like the one I've got here sat on the rolling road, will only be running at about half speed. To get to that achievement, we use in train controller, and then we come into the panel where we set up its name, its length, the prototype's weight, its address, and when we get to the speed tab we can set its maximum speed and its power, and to pull up the proper profiling. They do have a facility for doing an easy version, but we go the full distance and use the rolling road and to test it at half speed in one direction. Just to make sure it will do the speed we need it to do. Yeah, that's fine for that speed. And forward, just hit the start button, and we'll attempt to drive it. At every speed step, from slow to top speed. Yeah, it's almost up to about 70 mile an hour. That'll do for prototyping the layouts. So now we know it can perform properly. So we know we've got the mid voltage and the starting voltage and the maximum voltage set up about right. Now we can set it in motion to do a proper rolling road, where it advances through each of these steps to find out how it performs, at what speed it does at each of these steps. So it knows if it's trying to drive it at 40 miles an hour, how hard it has to drive it to get it to go to 40. And we'll attempt to drive it at every speed step from slow to top speed. Now it's done it in the forward direction, it's going to do exactly the same in the reverse. And now it's done. Okay to that and close that. One final amendment is to restrict the route backward speed. As most tender locomotives in this country were limited to 40, 45, 50 mile an hour. Then we can save that. Having done that, we can now export that via Dropbox to be imported onto the main computer, and then we can take the values from the decoder and write them up onto the record sheet, and then enter them onto the database so that when we come and do a similar loco, we've got a starting point from which to start.
So the final bit that we're doing in terms of the locomotive acceptance process is to actually run it on train controller. It's gone through the mechanical process with Alan and Bernie. It's gone through the usability test with Steve. Ian's done all the profiling and checking that the sound chip is behaving itself, or this one is a sound chipped engine. Finally, we get it in train controller, attach it to a train. It's in a yard. I'm going to click it off and we're going to see what I'm looking for in this process. As you've just heard, is that actually it's starting off, all the sounds are being triggered in the right order, which gives me confidence we've got the right information on there. And finally, we'll go round the layout. And what I'm looking for now is to check that it goes round the whole of the layout just once reliably and stops. Oddly enough, stopping is the big problem. So it's going off in its way. And we'll be about another 5 minutes, it'll come back. So the train has gone all the way around the layout, It's just coming in here. It's got one more block to do before it comes in through the tunnel. What I'm also looking for is to see that the sound picks up as it comes out of the tunnel, because we mute the sounds as it goes through the hidden zones. And then the final crucial thing is, does it stop at the right place? You wouldn't believe, after all this testing, there goes the points. So she's just coming in through the yard here, and we should hear the sound pick up gently as she comes in through the yard. So you heard there the sound picking back up again now. So the bit that I'm watching for is to see, will she stop at the end of the yard? Well, she's failed on one count, which is that the couplings are not reliable enough to pull a train round McKinley, so that's back to the board. And as you can see, she's also failed to stop at the red signal at appropriate distance. So back to Ian. Hoi.